indirectly I'm discussing numericals. To be frank, indirectly I'm discussing the numericals. Let's get into the, all of you put effort, because almost all numericals are based on the idea which I'm going to discuss now here. This is the some, you can say, like a disk of mass m and radius r. Velocity of center of mass vc, and all points are rotating about center of mass here. It is having a pure rolling motion. So I'll give one condition. Let vc equal to r omega c. There's a point on the ground. So you are standing here. Let me appoint one more person. Let the person be at the point of contact at that instant. Then let me measure angular momentum about axis passing through point G perpendicular to plane, also about point P. And let me take some other. Let the person be here, another person. So let me take point A. So what about the angular momentum all? That we'll try to calculate here. Now first LGZ. So is it okay now? So this is the x-axis. This is the x-axis here. No. What is the basic definition? Angular momentum due to rotating motion about center of mass plus angular momentum due to translatory motion of the center of mass here. Let me write it here. Now, what is LCM bar? It's a disk I'm calling of radius r, mass m. So this, I think you're going to write IC omega c. Tell me like a minus k cap or plus k cap? Minus k cap. How to get this r bar? So what is the basic formula? This will be m into rc bar cross vc bar. Can you go back to the definition? This is what is minus ic. This will be m r square by 2. Moment of inertia about an axis passing through center of mass and perpendicular to plane. Ic z, if you want, you can write that much on. So, and this is omega c. Keep it here. Now, what is the angle between rc? What is rc bar? From where rc bar has come? This is what rc bar. This is theta. So what is the angle between RC bar and VC? Should be theta. So this will be RC, VC, sine theta. What about this? This also minus K cap. What is omega C? Omega C you can write as VC by R. M into RC sine theta. What you can write RC sine theta? This is RC, this is R, this is theta. So sine theta equal to R by RC. So RC sine theta you can write as capital R. Minus K cap. So how much it is finally? 3m VC R by 2 K cap. This is angular momentum. What is the axis? Where is the axis? Axis is passing through point G and perpendicular to plane. LGZ. Please do remember. This is very important. You should know where is the axis. If you don't know that axis, no use of learning this. I'm making clear. And it is all points are rotating about center of mass like this. And center of mass moving. So how the motion of the rigid body? Rolling motion. Wheel of a vehicle. I don't like to repeat again and again. Please do understand. Wheel of a vehicle. Sir, I have not seen how the wheel will move. Then your problem. Teacher will not help you beyond this. Okay, how the center of mass will move horizontally. What about all points? All points will be rotating. Then with respect to ground, how do that will be? The points will have both translative as well as rotative. Later part we'll discuss here. Now I want LPZ. Now what should be the formula now? LPZ. LPZ. Again, I'll stick on to the same thing. Angular momentum due to rotating motion about an axis passing through center of mass. Clear this? And angular momentum due to translatory motion of center of mass. Let me keep it like this here. Then, what is LCM? Again, it should be same. IC omega C K cap. There's no change in this. What about translatory motion? M into R PC bar cross VC bar. Shall I change this? Earlier, this was RC, no? So now RPC bar. And what is the angle between RPC bar and VC bar? Oh, this one. This is 90 degree. So therefore the expansion and how it will be. Okay, let's substitute here now. Next step. Or here only I'll write it. So this should be equal to minus mr square by 2 VC by R K cap. Then M into what is the angle between RPC into VC sine 90 degrees. Minus of K cap. Get into this one. Okay, next step will be minus MVC R by 2 K cap. Then what is RPC? RPC is in fact equal to R only, no? Capital R. What is the distance? Equal to capital R. So what we are getting? MVC R K cap. What we are getting answer? Same. Either you apply angular momentum of an axis about an axis passing through point GA, or you measure about this, it will be same. This is something very fundamental for us in the rolling motion. If you don't know this and you are studying rolling motion, I don't know what you are studying there. Finish over. I'm making things clearer. First, you should know the basic theoretical ideas. Without that, I think you do whatever numericals and you don't know that, finish short. So when you go for the KVPY exams, then any other interviews, no, they'll ask you such small ideas. They'll ask you to derive. I think last year or 2 years back, they asked them to derive. And the students, what happens? What students are telling, sir, we know how to use formula. You give any question, we'll solve. They told, like I say, what is the use of learning when you don't know how it came? Then they ask them to derive. So this is what happens. Like I say, they won't like say when you are going for research. What happens? It's not like something you know some information, with that information will manage. No, research is something where you must have a clarity of the subject. Not like how many numericals you know it. Literally, the students, they though I taught them in class, no, the students are replying back to teacher there in the interview, KVPY interview. Like I said, like you can ask any question, we'll solve it. The professor was headband, no, you derive it. So clarity is needed, not like you should know. Knowledge is not just like a gathering information. Knowledge is something you're supposed to analyze. You must have the ability to analyze that one, how it has come, what should have been that. This the preparation is what needed. Now, let me calculate about a LAZ. What about LAZ? Again, it will be same, minus IC or omega C K. Then RAC bar cross VC bar. What is the angle between RAC bar and VC bar? 0 degrees. So this expansion of this will be minus mr square by 2 VC by R K cap M into RAC VC sine 0 degrees. So this quantity, what happened, will become 0. We'll end up with now you have to ask question. So what is this? Like when you measure about P, LGZ equal to LPZ, but we are not getting LGZ equal to LAZS. About different points will be different here. And now, sir, can I measure about point above, somewhere here above? Yes, you can measure about this point also. Later, I'll show that one because let me introduce for rolling idea. So this is about the how to find out the angular momentum of a rigid body which is rotating. All points of the rigid body are rotating about center of mass and center of mass moving horizontally. This is one basic idea. Okay, let's one small. This week we don't have conservation of angular momentum. I think you should try to avoid any discussion on that. I'm making things clear. But for rolling motion, we need all this background. So suppose say this is a rigid body. Let me take a sphere. And this is the axis. One axis is this one. It's having only rotating motion. This axis passing through, it is rotating. Center of mass like this. This is a solid sphere.